passage and population monitoring. I'll talk in detail, maybe excruciating detail, about population monitoring and sort of what you can and can't learn from the information that we currently have. We talked a little bit at the Freeman about riparian birds. We didn't talk about least terns. A quick aside, California least tern, they're mostly an oceanic bird. They nest on sandy beaches, but we have observed them on our facilities, mostly foraging in some of the ponds and ponded areas, but there has been, I think maybe 8 years ago, they did find a chick in one of our percolation ponds, and it was dead. And so people were like, oh, well, maybe they're nesting nearby. So we've spent quite a bit of money and time having folks going out and monitoring and looking for least terns breeding on our property. It's unlikely that if they did breed there, that they would succeed in breeding there. Mostly they like sort of little islands that are isolated with no vegetation, and where predators could be easily avoided. We don't really have that. We mostly have like gravel roads, which is a great place to make a nest. And then things like wetland delineation. I don't do too much of the wetland aspects, so I won't spend any time.
What is that like?
So
restoring wetlands?
So wetlands have a legal distinction.
Mm-hmm.
So Army Corps has a legal distinction on what constitutes a wetland, and I'm going to get it wrong, but it's something to do with soils, vegetation, and evidence of actual hydrology in the area.
Yeah.
And so in the context of doing something like building a fish passage facility, we need to delineate the wetlands that might be impacted by our facility.
Like Ormond Beach at the end of it, at the outflow, or is that more local? Is that like Ormond Beach at the end of it to the ocean, and those wetlands, or is that just more localized wetlands too?
So wetlands have just very specific delineations, and anything that has evidence of like long-term wet soils, vegetation that is indicative of that long-term wet soils, and then evidence that basically there's been flow in that area, so you can look for like debris racks and stuff. So if you're in a river, an area that has, like sticks and twigs and leaves getting washed along it could potentially be a wetland, but there's specific delineations and a guide on, okay, you have to have this component and this component and this component, and then kind of make a judgment call on how do those all fit together, because maybe you have one of them but not the other two. Is it a wetland?
And that partially dictates like your guys' flow too. Like, because if you guys put too much flow, you might like wash it out kind of, or if you too little, you'll dry it up. Or
not in the current. We haven't really been dealing with wetland in the current context. Mostly the wetland that we've been worrying about has been disturbance to the wetland by building a facility.
Okay.
Okay, I'll talk a little bit about FERC, which is the Federal Energy Regulatory Commission, which regulates our operations of Santa Felicia Dam and Lake Piru. And my first example will actually be of an anadromous species, steelhead, and then I'll also give you an example of some non-native species management that we've been doing up there. And non-native invasive species management, both quagga mussels will be the example that I'll talk about mostly, and bullfrogs, but some of our other folks are working on noxious weeds, and I've done some work, published some work on non-native fishes. Okay. So, how do we do this? How does United, which is a fairly small organization, actually accomplish environmental monitoring? We currently have 3 full-time staff ecologists, myself being one of them. We have an environmental scientist who sort of leans more on the environmental permitting aspect of things, so all of our projects often need a permit associated with it, whether it be from California Fish and Game, U.S. Fish and Wildlife Service, Army Corps of Engineers, California Water Resources Board. All of those organizations have permitting requirements that we often have to meet. We hire a slew of environmental consultants to help us with particular projects and places where they either have expertise or personnel that can get our tasks accomplished. And then we also collaborate with other agency scientists to basic research and in developing our plans. And this is, I would say, probably more than half of my job is working with National Marine Fisheries Service and State Fish and Game on trying to develop plans for steelhead. Okay, so let's first talk about effectiveness monitoring. So effectiveness monitoring is most of our plans have been developed with something called the best available science. And best available science sounds great, right? The best available science means it's the best that is currently available. It doesn't necessarily mean that it's terribly great, but it's what we have. And in a lot of environmental contexts, you don't necessarily have great information, but you still need to be able to make decisions based on it. So let's see here. So how do we address whether these operations are meeting our biological goals? So I'm going to give you an example on how, for our Santa Felicia Dam project, we have tried to address some biological uncertainties that we have with the operations that we're proposing to do. And we're doing this through a hypothesis-driven framework. And we're trying to combine that with adaptive management. So as we get information through our monitoring process, can we feed that information back into the program and make changes if there's changes necessary? All right, so here's an example of an uncertainty. So we'll have some sort of focal management action where we don't really know what the responses are, and our data aren't sufficient to give us confidence that we know the answer. We develop a study question and determine how our monitoring program can resolve the uncertainty. We have a goal, right? So the whole point of our operation is to achieve some particular goal. So we have a desired result, and it's a component of our management plan. And then we have a biological objective. And this is how are we going to assess whether this biological goal is met. So we have some analysis, often of quantitative results, that's going to determine whether we're being effective. And I'll give you an explicit example of this, so you don't have to stress out too much about the details. Hopefully it'll be more clear when I give you a specific example.
That's clear.
But I want to sort of refresh your memory of the Santa Clara watershed. So this blue dotted line is United Water Conservation District's boundaries. So these are the areas in which we're managing groundwater resources. We're going to be talking about Lake Piru and Santa Felicia Dam. And the Santa Clara watershed is semi-arid. We don't typically get that much rain, and that rain is disparately distributed throughout our watershed. The upper watershed doesn't tend to get nearly as much rain as sort of the mountainous areas in the Sespe and Santa Paula Creek drainages. The Santa Clara River proper can be, I'd say, described as an interrupted perennial stream. So that means there's sections of the river that are permanently wet, and I think we talked a little bit about this at the Freeman. And then there's sections of it that are intermittent, that in dry years they'll go completely dry. In really wet years they may be wetted, but not nearly to the same extent as the perennial sections. And so this is a really important component when we're talking about steelhead management. I talked a little bit about this at the Freeman, that these perennial reaches are really being controlled by where you have tributaries, the valleys narrowing, and that bedrock's close to the surface, keeping the water also close to the surface. And in terms of steelhead, there's a really extensive network of mountainous perennial streams. Though some of those tributaries, some of the really small ones further up in the watershed will often go dry. But then you could go and say like the upper Sespe and Potrero John Creek, which is a tiny little creek, and even in the midst of the drought, it still had water and actually trout in it. So the other really big issue for Southern California steelhead is that there's very few returning adults pretty much anywhere within the boundaries for this species or species. And the Santa Clara in particular, we've had really low downstream migrant numbers. And I'll talk again in excruciating detail about those smolt numbers and what we can and can't say with that.
Does smolt necessarily indicate downstream?
Smolt is a downstream migrant. A smolt is one that has physiologically transitioned for life in the ocean.
Thank you.
They can transition back to being a resident trout if they can't make it to the ocean. Okay, so let's talk a little bit about Pirate Creek and Santa Felicia Dam. So Lower Pirate Creek was historically intermittent. So the segment, how many of you guys been to Pirate Creek? Lake Pirate? Very few of you. So this is in the upper part of the watershed, closer to LA County. This is a very dry, arid section of the watershed. The lower part of Pirate Creek was historically intermittent. It didn't connect to the Santa Clara River, and I'll show you that the Santa Clara River doesn't usually flow in the area where Pirate Creek comes in. The upper part of the watershed does have perennial flow. Agua Blanca, Middle Pirate Creek had perennial flow. And that's where the major habitat for Omaha is. So Pirate Creek joins the Santa Clara in an area of really high percolation. It's something, a corollary to that segment downstream between the 118 and the 101 bridge where there's really high percolation. And it's really, really obvious if you look on Google Earth. So this is basically Newhall Land and Farming, and LA County line is right about there. Just look at the riparian vegetation. In this area, you're still getting green, you're still getting riparian vegetation. A lot of this is actually driven by wastewater outfall from Santa Clarita, Valencia. As you go downstream, you get this wide sandy channel, and this is a really highly percolating area. And even in the 1700s, when Father Crespi was exploring this watershed, they described this as basically a desert. If you're steelhead, this might be a challenging area for you to get through, and I'll talk about this in detail. So, as part of our water release plan, so when we received our FERC license, our relicensing of our facility, we were required to consult with National Marine Fisheries Service about the effects of Santa Felicia Dam to steelhead. Santa Felicia Dam was built in 1950, and people did not have any conception that steelhead were even an issue at that point in time. The Freeman people did have a conception of steelhead, but Santa Felicia Dam, not at all. So there's no fish passage, there's no anything. If you're a fish downstream, you're okay. If you're a fish upstream, you're never getting to the ocean. So as part of the relicensing process, we had to develop something called a water release plan. And that was, okay, what are the fish needs? When should we release water for fish? And I'm going to talk about an example of migration flows, though at some other point I could talk to you about habitat releases and basically just trying to achieve components for the steelhead life cycle. In this case, the biggest part of being a steelhead is migrating to the ocean, so that's the one I wanted to talk to you about. Our migration flows from Santa Felicia Dam, we release 200 cubic feet per second. So when you guys were at the Freeman, I want to say it was about 50 cubic feet a second, 50, 60, somewhere in there. So a fair bit more water coming out of a much, much smaller creek. Pirate Creek is probably, when it's flowing 200 CFS of maybe from here to the wall. So a much smaller creek with a lot more water going down it to provide migration flows to steelhead. We have a trigger, and this has been a very complicated trigger, is Santa Clara River at the Newhall gauge, which is basically right at the end of that, or about the beginning of the losing reach, has to exceed 200 CFS and be forecast to exceed 200 CFS for 24 hours. This was sort of a compromise decision that ended up going through, what's the term? This was before my time, but they,
Did they form a committee?
it wasn't a formal committee, but basically they had to pull in a mediator. It had to be, there was a formal mediator because NMFS and United could not agree on what they thought appropriate flows were. And so it ended up just being a consensus, not really based on science, just a consensus on what could NMFS and United agree to in terms of water resources.
Do you know where that guy came from? The mitigator?
I would say, I don't. We could look at it. And then in terms of ramping, one of the components for steelhead is you don't want to strand them. So you don't want your water going up too fast or down too fast because fish could end up, out in the margins of the river and then the water goes down really quickly and it didn't make it back into a wetted area. So thinking about ramping rates. Okay, so here are some of our questions. Do these migration releases actually provide passage through Pirate Creek and the Santa Clara River? And when we're releasing them, is this appropriate for matching natural opportunities that might have been encountered in this watershed? So let's talk about some of the challenges that we face. One of the biggest challenges that we've faced with, particularly with Santa Felicia Dam, is that we don't really have a reference stream. Pirate Creek is basically the furthest up in the watershed. It's a very dry watershed, and so there really isn't a great comparative area, and there aren't very many rivers that are similar to Pirate Creek. So we're looking for something with relatively healthy in-stream and riparian habitat that's supporting healthy populations of Oomycus to give us a context for what are you comparing your success to.
Oomycus or the steelhead?
So Oomycus is the general term for rainbow trout steelhead.
Okay.
It's the same species. Oomycus is more broad because it encompasses both life history strategies. So the next challenge is how do we determine these appropriate reference conditions? So I've already mentioned there aren't really great reference streams to immediately go to and say, is the stream look similar to Pirate Creek? So we can go in the literature, and there's not really very much available in Southern California. And if we take, say, parameter values for fish flows or duration of flow from, say, Washington, is that going to be representative of what's going on in Southern California? The environmental context is very different. The evolutionary context is different for Southern California steelhead. So maybe or maybe not, these could give us the realm of possibilities, but maybe not the specifics. The one little tidbit that I wanted to throw in with this literature segment is I had a technician in the past who was a CCI student, and he was complaining vehemently about having to do a literature review. And I want you to know, as a professional in this field, literature reviews are like the most important part of your job. You need to see what's out there, you need to understand the context of the science that's known, and then maybe you find gaps in that knowledge and you identify new paths forward. But if you can't do a literature review, you can't synthesize the stuff that's known, find another field. I think this is the best advice.
Don't complain on the job, right?
Well, he wasn't. It was for class here. It wasn't for me.
Yeah.
I don't generally have my text teach. So then we have some preliminary analyses. We have some limited hydrologic records for Pirate Creek without the dam. So there was a gauge on Pirate Creek, so they can somewhat assess what was going on in the creek in terms of flows before the dam was there. But there's really highly variable hydrology at the watershed level. So one of the, I'm not sure if Linda talked about it in class, but one of the big challenges in Southern California is like, what is average? What do you describe as the average hydrology for a system? Often people are talking about like average rainfall from an area, but actually in Southern California, it's actually kind of bimodal. And I assume you guys, bimodal, that means?
Yeah.
Two different models.
So basically, if you have a distribution, you've got two humps.
Two humps and
So you've got rainfall here on this axis, and you're going to have maybe two humps, and this is counts, number of years.
not a drama here.
Yeah.
So this is pretty typical, and this is very typical with our hydrology as well. You kind of have really wet years, really dry years, the average years. If you do a numerical average, it'll be like, oh yeah, it's in the middle, but we don't necessarily get the average that often. Okay. And then there's things like standard operating procedures. California Fish and Game has developed a standard operating procedure for something called a critical riffle. And I can distill a critical riffle analysis into something very simple, trying to identify the most challenging section of a river and how much water needs to be going through it for fish to be able to pass. And in many streams, a critical riffle So did you guys talk about riffles?
No, we haven't. We were very close. But we didn't
Very
quite
close.
get it.
So there are really 4 components in a stream. There's riffles, runs, glides, and pools. And riffles are basically the segments of a river where you see the surface really disturbed. It's typically a changing gradient, and it's usually where you see white water. In many coastal streams, those are going to be areas where the water is going to be potentially the shallowest and the highest velocity, and those are maybe the biggest challenges for the fish going through. This may or may not be appropriate in the Santa Clara River. You guys saw the Santa Clara, big sandy wide channel. Riffles may, in some contexts, be a challenge, but also you may have, 100-foot long, this deep, but 100-foot wide sandy reach where the braids may not continue and the fish is swimming downstream, and then it ends up at a dead end and has to go back upstream and go to another route to be able to successfully get upstream. So this standard operating procedure explicitly says not appropriate for sandy streams, but it's really the only SOP out there. Okay. So
where are those SOPs
People type
federal, or are those like just like
people develop them
United?
for, so this is California Fish and Wildlife.
Okay.
Different agencies will develop them for their contexts. This is loosely based on something called the Oregon method. So they took their standard operating procedure and based it on previous groups' analysis. But
Is there a push right now? Like, are they trying to come up with new SOPs for sand-dominated streams?
there aren't very many of them. So you can pretty much put them on Southern California steelhead and kind of need fish to help you with this. So this is a challenge, and it's something that we would like to address in the future, but we haven't had it. Okay. So the next challenge is what I call the Field of Dreams problem, and it's really, okay, so the only thing I'm talking about here is water releases. Water releases in terms of a migration event for steelhead. If you provide that migration event for steelhead, will they return? In some contexts, yes, it's been absolutely true. The Elwha Dam removal showed that fish were waiting and made use of the river immediately. Whether that's true in Southern California, there may not be as many neighboring fish that could stray into this river. I don't know. It's definitely one of our uncertainties. And how many of you guys have done anything with statistics? All right. So you probably have had an experience in statistics where, or maybe in your capstone projects where you're like, I don't really have enough data to even make a distribution like this. Like, what do you do with 10 fish?
Yeah.
That's probably not representative of the population on the whole. So how do you make decisions based on really small numbers of fish? So, and this is a little small. So they get really silvery and they have black tip fins and their scales start falling off. Okay. So all that long setup to say, let's go back to these questions and see, do our migration releases provide passage? Does the timing match up with natural opportunities? And will these impact spawning success? And I'll only really talk about one little subset of this. But I wanted to set you up with that uncertainty, study question, biological goal, etc. In the context of this, because this is actually what we literally wrote in our effectiveness monitoring plan. Just trying to set this up so NIMS understands we have a hypothesis we're trying to test, and this is the data we're going to gather in order to be able to do this. So you don't have to worry about the specifics, but the basic idea is, does our initiation trigger, that 200 CFS in the Santa Clara River, make an appropriate event for fish? Is it going to allow them to be able to migrate down to the ocean or migrate up into Pirate Creek? So our study question was, does this initiate, this flow trigger initiate the appropriate timing and frequency when fish passage is possible? Our goal is to provide unimpeded migration for fish. So this is, if our flows aren't meeting this, if our flows aren't providing a opportunity for fish to be able to migrate in an unimpeded fashion, then we're not meeting our goal. And we're going to evaluate the effectiveness of this by using some of our data, and I'll talk about this in a little bit. So, the parameters that I was able to use. Average daily discharge for the Santa Clara River from a historical record. Our migration release schedule, so I know I can take that model, that data from the past, and then model when would we be releasing water based on those criteria. And we're still in the process of trying to develop what are passable criteria for fish, and how quickly do fish need to migrate. So that fits into how long do you need to have flows available for fish to be able to get through. If you only have, say you had a storm that was really short and it only went for 1 day, is that worth the water resources if fish couldn't actually migrate through that section in a day? So that's the sort of balance that we're trying to achieve. All right, so I'll show you a little bit of the data that we have available. And so this is from 1997 to 2007. And our flow plan would specify in 1997 a normal year of rainfall, so it's sort of the middle 50% of years. There would be 5 days in which there would be migration flows. In a wet year, you could have almost 100 days. Basically, the river is going to stay flowing all year round. In a dry year, you could have no opportunities for fish to migrate. So this is the number of total.
What? See, I haven't used this one, I don't know.